This is day 19 of our Leetcode daily question series, and today's question is minimum number of k consecutive bit flips. In this question, we are given with a binary array nums, so the values in the array will be 0 or 1 only, and a bit flip is choosing a subarray of length k from nums and simultaneously changing every 0 to 1 and every 1 to 0. That means if we are like in this case, the value of k is 1. Now, let's see this case. If we choose this array, we will toggle all the values. Which means this one will be converted to 0, this one will be converted to 0. And if we choose this array, this part of the array, this one will be converted to 0 and this 0 will be converted to 1. So this is a k-bit flip, and we have to return the minimum number of k-bit flips which are required so that there is no 0. The whole array is 1 1 1 1 1 1 only. And if it is not possible to convert the array with no zeros after doing this operation, the k-bit flip operations, we have to return -1, and a subarray is contiguous part of an array. Simple. So let's see this example third. In this example, what we can do, as we encounter a 0 here, so we can simply toggle these three values. Okay, so the array will look like 1 1 1 here, and 1 is also here, and we again encounter another value which is 0, so we'll toggle these three values. So the array will look like 1 1 1 1 1. This value will also be 1, and these one will be converted to 0. So the last three elements will be 0, and when we encounter the last three element L 0, and we again toggle these last three elements, so the whole array will look like 1 1 1 1 1 1 1. Okay, so in this case we have to toggle only 3 times, total k bits only 3 times, as it is explained here. Okay, so in this case output will be 3, and the given constraints are this: k will be always less than equals to nums dot length. And let's see the code.
So considering this example, in this example the given array nums looks like this and k is given as 3. Now as k is given as 3, we can swap exact 3 element at any point. So what we can do is we can just simply swap these 3 elements, so the array will look like this: 1 1 1 1 0 1 1 0, and just take a pointer I here, iterate it from left to right. At any point if we find a value 0, then we will swap these 3 indexes, these k indexes values. Okay, swap next k values including the value at I. So if I is at 0, 0 1 2 3 4 5 6 7, so all these 3 values are swapped. After this, the I will be moved here, and we will again check, and now at this point value of nums of I is 1, so we don't need to swap any value. I will move here, 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 and here we will again encounter another value which is not equals to 1 and equals to 0, so we have to swap this value, as we have to make whole array equals to 1. So what we can do is simply, we have only one choice: we have to swap all the k elements in the range starting from this point. So we will swap these elements, and now how array will look like is this: 1 1 1 1. This value is swapped, so it will be 1, and this value is swapped, or you can say toggled. I will use swapped, so it is 0, it is 0, and last value is also 0. And now as I was here, I will be shifted here. Again we encounter a value which is equals to 0, so we have to again swap the k elements starting from that ith index. So array will look like this, and after this I will be here. Again it is 1, so we don't need to swap. Again I will be here, it is 1, and I will be out of the range of the array. At this point we will break the loop, and if I reach here, so we will return the count of the how many times we swapped elements. So first we swapped elements here, so initially count was 0, and at this point count was updated as 1. Now at this point when we swapped here, so count was updated as 2, and at this point count was updated as 3. So we will return count after execution of whole loop. Okay, so let's take another example to understand more thoroughly. What can be another case is if this value was 1. Okay, if this value was 1, so like if this value was 1, what array would look like is here, rather than 0 it was 1. Okay, so when we swapped at this point, the array changed into 111 for last 000 index. But if let's assume this value was initially 1, so this value will be toggled to 0 when we change in these three ranges. And when I comes to this point, now we can't change any k elements because there is no value after this point. Okay, so the range of I plus k is greater than n. Okay, so if I plus k is greater than n and we encounter any value as 0, in this case we have to return -1 because we can't change array in some way so that it can be changed into all one. Like if you think we will change this point again, what the array will look like 1 0 0, and now you have to again change this point, so these 0 will be changed to 1 1, but this one will be changed to 0, and it will go on, and array will never change to all ones in this case. So if at any point if we encounter I plus k is greater than n and we have to swap the values and we found 0, nums of I is 0 and I plus k is greater than n. So in this case what we will do is we will simply return -1. Now what can be the brute force approach is to simply traverse from left to right taking a pointer I, and at any point if we encounter a value which is not 1, which is equals to 0, we will swap the next k indexes. Okay, so at this point, like if our array was something like 0 1 0 1 0 1, something like that. So at this point let's assume k equals to 3, k equals to 2. What will happen is we are traversing from left to right, so I is here. As we encounter a value, so what we will do is we will swap these k elements, so the array will look like 1 0 0 1 0 1. After this I will be shifted here. Again we encounter a value which is not equals to 1, which is equals to 0, so we again swap k elements, so this will look like 1 1 1 1 0 1. And in the worst case, we can, the maximum time we have to change the value can be I, so because I is going from left to right. Okay, so I is going from 0 to the size n-1. Okay, so what will be the brute force approach complexity will be big of n into k, which is a very huge size, which is a very huge complexity. So we have to optimize this complexity by taking some space or any method. Let's look at those methods. Now what we can do to reduce complexity is we can take a variable count flips, which will store the total number of count flips in any range, in the previous range only, and we can create a hash map. Okay, so we can create a hash map for the following. Let's declare a vector of size, same size n, and putting all the values 0 initially, and at any point if we toggle any value, we will just simply mark the hash map value to 1. Like at this point we have to toggle the value because it is 0, so what we will do is we will change this value and we will mark it as 1. This one shows that at this point the value of count flips was increased. As we any point flip at any point if we flip any number, we have to increment the value of count flips. Okay, so as we toggle the number, so we update the value as 1, and now the k range given was 3. Okay, so k was 3. So in this case all these values are toggled, but we will not run a loop from left to right. We will toggle these values while traversing with I. Let's see how we will do that. Is as I was here, now I is here. At this point we will check the value of count flips. As the count flips value is 1. Okay, so we know that this value was toggled. Okay, so this value was toggled, so this value is actually not 0 but it is 1. Okay, because it was toggled when we changed the value at this index, as all these values were toggled. Okay, so this value is actually 1, but we didn't mark it 1 on also, and we will just see the value of count flips and we will check if the value is 1 or 0 or whatever else. So at this point we don't need to increment the value of count flip. We don't need to flip the values at the next range. Okay, So we will not put value 1 here. Now I will be shifted here. Okay, again we will see that the value of count flips is 1. Okay, so the count flips value is 1, so that means this element was toggled once. Okay, so this element is actually not 0, it is actually 1 because it was toggled once when we were at this point. Okay, so at this point again we don't need to toggle any value because we have 1 only. Now again we will go to here. Now when we are at the range of when I is equals to greater than equals to k. Okay, so at this point the current index is, let's mark the current indexes so that you can understand properly. 0 1 2 3 4 5 6 and 7. Now as k was 3, so at this point this condition will satisfy. Okay, so if I is greater than equals to k, now we have to check if the value which is not in this range. Okay, so if this value was toggled only if any value was toggled in this range. Okay, now because if we toggle this value the range will be this, if we toggle this value the range will be this, so it will fall in only those two range. But if this value was toggled, the range was only this much. Okay, so this value was not toggled at this point, but the value of count flips is 1 here, so we can assume, so we will assume that this value is toggled. So what we will do is we will just check if the value of I is greater than equals to k and value at this point which is I minus k. Okay, 3 minus 3 equals to 0, and value at this point, the value of v of I minus k, if this value is 1, which means this value was toggled, so count flips was incremented here, so we have to decrement the count flips. Okay, so if these both conditions satisfies, what we will do is we will just decrement the value of count flips. Okay, so we will decrement the count flips, so count flips will be again equal to 0, and after decrementing the count flips, now we will again check what is the actual value at this point. So we will check the value is 1 and the value of count flips is 0 currently here, so it means the value is same as it was here because the number is even. So if it was toggled even times, it will be same, of course, 0 1 0 1 0 1 also. So it was toggled 0 times, so this value is 1, so we don't need to change the value or toggle the value, so I will be moved here. Now again we will check if this value was toggled. Okay, if this value was toggled, we have to check at every point when I is greater than equals to k. If this value which is just before the range of this value is toggled, we have to decrement. Okay, but at this point it was not toggled as the value is 0 here, and now we will just see the value of count flips. So the value of count flips is 0, that means it is the current value, it is the correct value. Okay, it is not a toggled value. So what we will do at this point, this is 0 and we have to convert it as 1. So what we will do is simply convert it into 1, and whenever we convert a value into 1, whenever we toggle a value, we have to take care of the value here, and we have also convert this 0 to 1. Okay, to check further if this was toggled or not. Okay, and as we toggle the value, so we will again change the value of count flips and we will increment the value of count flips, which will be incremented to 0 plus 1 equals to 1. Okay, now as this value is also toggled, so what will happen, the I will be moved here after this, and now we will check if the value of, if I is greater than equals to k, of course I will always be greater than equals to k in this range. Okay, so vi minus k if double equals to 1, vi minus k is what, 6 minus 3 equals to 3, so this is equals to 0, it is not equals to 1, which means we don't have to decrement any count flips as we discussed before. And now what we will see, what is the current element at this point. We see the current element as 1 and the value of count flips is 1, so it means this value is flipped once time. Okay, this value is flipped once, as we flipped a value here, so the values in the range of I plus k will also be flipped, so this value is flipped 1. So what is the current value is 0. Okay, so if the current value is 0, we have to flip all the values. So what we will do is simply flip this value, again increment our count flips counter, Okay, so it will be shifted to 2 and this will be marked as 1. Okay, now this is marked as 1. Again I will be incremented here. We will check if the value 6 minus 3 is 0, so we don't have to decrement count flips. And this value is toggled 2 times currently, so it was 1, then again it was toggled, so it was changed to 0, again it was toggled once, so it changed to 1, and the current value is 1 only. Okay, so we don't need to toggle the value. Now I will be moved here. So first condition, what we will check? First we will check this and then do the operations. So first we will check this, and at this point we will see that vi minus k, which is 7 minus 3, which is v of 4 equals to 1. So the count plus value is greater than the value which have to be the current count flips. So we'll decrement the value as I discussed before. So this value will be decremented to 1. Okay, and now we will check what will be the current value at this point. So at this point the current value is 0, but the value of count flips is 1, so this value is toggled once. So what the value was before is 1. Okay, so current value is 1, so we don't need to toggle, and then I will be moved here. And at any point when we toggle a value, we will just update our counter at every point. So counter was 0 initially, at this point counter was updated to 1, at this point counter was updated to 2, and at this point counter was updated to 3. So 3 will be our final answer. And at any point if I plus k greater than n, what we will do? We have to return. Now in this method what we are doing is we are just simply iterating from starting to ending with the pointer taking I. So the overall complexity will be O of n, but we are also taking the vector, okay, a hash map space for storing the values, storing that if there is a toggle value or not. So what will be space complexity? The time complexity is On, and the space complexity will also be On. Okay, but notice we have to check only at the index vi minus k. We don't need to check before that, so we can convert it into O of k. Okay, as we need to check only the kth element before the current element to change the value of count flips or not. Okay, so as in the given constraints, k will always be less than n, as k is the range. So we can reduce the complexity, reduce the space complexity by taking some sort of data structure which will help us. Now what kind of data structure we need? As we have to push the values, as at this point we toggle the value, so we push 1, again we toggle the value, we push 0, then we push 0, and at this point we didn't toggle the value, so we have to push 0, but as this element is processed, we have to pop out this value. Okay, again after this 1 will be added and we will pop out this value, then this 1 will be added, pop out this value, and so on till I reaches the end. So what can be the data structure in which we remove the first element, in which we remove from the starting and insert elements from the ending? So correct, the data structure is Q. In Q data structure, the FIFO manner in which we have to insert at the starting, at the front end, and delete from the front end and insert at the rear end. Okay, so we will use Q data structure to optimize our space complexity. Okay, so let's simply write the code. So let's write the code. Let's first declare some variables. So I will use for iterating. Count flips we will use to store the value of the flips which are toggled. Okay, and the overall count that we have to return. Okay, only these 3 variables. Now we also need to declare the queue, as I discussed before, to maintain the value. And also no, we don't need to check after as we are using queue here, we don't need to check vi minus k. Vi minus k will always be the front of the queue, so we will check by q dot front. Simply q dot front will be vi minus k, as we are popping out every element from the starting. Okay, so let's write the code. Now just simply run a loop for the I, which will start from the 0 and run till the size of the given array, nums dot size and I plus plus. Now in this for loop, first we have to check this condition as I explained. If this condition, then the value of count flips will be decremented. So simply write if I is greater than equals to k, same as I wrote it there, same as I wrote there, q dot front double equals to 1. Okay, simply if I greater than equals to a and q dot front double equals to 1. Okay, so at this point what we will do, we will simply decrement the value of count flips. So count flips will be decremented, and now we will simply check if the value needs to be toggled or not. And how we will check that? Like, let's take example. So if the value of count flips is 0, okay, and the number is odd, okay, so we have to toggle, because if the number is 1, if the number is 1, we don't need to toggle, okay, because we have to keep the number 1 in the array. But if number is 0 and the value of count flips is 0, है ना, so we have to toggle at this point. We have to increment the value of count flips. And also for the even case, if the value of count flips is even, okay, let's assume it is 1, and if the number is 1, in that case number is 1 and the count flips is even, which means the number was incremented odd times, so it will be converted to 0. So in this case we have to toggle. And another case can be if the number is 0, we don't need to toggle. So you can simply see if the number is 1 and the value of count flips modulus 2 is also equals to 1, which means it is a odd number, we have to toggle. And also in this case you can see if the value of count flips modulus 2 double equals to 0, which means the count flips is an even number and its number is 0, we have to toggle. So what formula we can write? If nums of I, the current value, which is 1 or 0, is same as the modulus of count flips, then we have to toggle. Okay, simply we derived from this part. So this is the formula we will use when we have to toggle a value. So what we can write is the same: if nums of I double equals to the modulus of 2 taken with count flips modulus 2. In this case we have to, first what we will check is, as I explained, when we, like in this case when this value was not 0, if this value was 1, in this case what will happen, we have to, as this one changed to 0 later, so this value is 0, okay, and we don't have any extra space here, any k elements here, so we can't toggle this value and we can't convert this array into all ones. So at this point we have to return -1. As I explained, if I plus k is greater than n, we have to return -1. So we'll just simply write that first. So in this if statement, we will write the first statement as if I plus k is greater than the size of the array, size of the given array, then we have to simply return -1, because we can't generate an array of all ones by following these procedures. And if this condition not satisfies, in the else case, what we can write is we have to push the value 1 in the queue. As I explained, we will, in the queue, as I declare queue as queue, in the queue we have to simply push the value 1 if we toggle the value and push value 0 if we didn't toggle the value. So we will, in this point, as this nums of I double equals to count plus modulus 2, in this case we have to toggle the value. So what we will simply push 1, and after this, if q dot size is greater than k, because no, for these three elements when we are pushing in the queue, we don't need to pop out any point, any value, but when we push the fourth value, we have to pop out this value. Okay, so the maximum size of q will be remained as k only. Okay, so when we push the k elements and the size of q is greater than k, when we push the k plus 1th element, so what we have to check, what we have to do is simply pop out the element. Okay, and all the values as count will be incremented as we toggle the value, and the value of count flips will also be incremented, which we are storing that how many flips are counted in that range, and this if statement can be closed here. Now in the else case, what we have to do, as we don't need to toggle a value, we will simply push the value 0 in the queue, and again we will check this and do this. So if q dot size is greater than k, we will pop the first element from the queue. Okay, and after execution of whole process, if I reaches the end of the size of the array, what we have to do, closing this for loop, we have to just return the value of count, how many values we toggled, simple, and we can close the function here. Okay, so this is our code.
Okay, so let's run our code. Let's submit the code. Okay, so the code is accepted, and there is another question on the Leetcode which is same as this question, but in that question the value of k is fixed as 3. So let's submit that question also. Let's copy this code, and now let's open the question, which is Leetcode 3191. Okay, 3191, and now this is the question. Again the same question, you can read, but the value of k is fixed as here it is written. We have to choose any 3 consecutive elements from the array only, and we can flip all of them, and we have to just make the array equal to all ones. So let's paste our code, and in this code we have to determine the value of k as 3 as it is given in the question. Okay, so let's run this code, passed all the test cases. Let's submit the code. So the code is accepted here also. Thank you for watching.